Alrighty, everybody, in this example, we are going to do lots of examples on ionic bonding. So it is really important that you know this gold ion sheet. It is literally worth its weight in gold. You have your different sets. You can have your periodic table out in front of you. Um, but you're eventually going to get to the point where you're going to have to know these guys for memory. All right, so something like ammonium being NH4 plus, and knowing that your zinc ion is a 2 plus and aluminum is a 3 plus. Those are things that you are just going to need to start to really work on. So have your flashcards, your Quizlets, whatever you need to do in order to remember them. Okay, don't forget that if you have a 1 minus, it can either be written as minus or 1 minus. So be really careful down here with all of your permanganates and iodates, hypochlorites, chlorite, chlorate, perchlorate. And all of your set 6 are going to have your 2 minus ions. So if you haven't seen the videos on Nick the Crafty Camel, definitely make sure that you practice those because these are going to be really important to what we're about to do. Okay, so here is what we're going to do. We are going to make some ionic compounds with the Criss-Cross method. So that means you need to know what all of these different things are. So if we bond the sodium ion to oxide, you find that sodium's in column 1, so it makes an Na+, and oxide is in column 16, so it makes a 2-. And then we are going to crisscross these and take this 1 plus charge here and this 2 minus charge here. So my formula for sodium ion and oxide makes Na2O. That is my neutral compound. Okay, with crisscross, we are always taking a positive cation and a negative anion second and making a neutral compound. Okay, this has to be neutral with no charges. So you get rid of the plus and the minuses at the top and you add them to the bottom. So there should be no pluses or minuses in your actual formula. All right, magnesium ion is in column 2, so that's Mg2 plus. Bromide is in column 17, so that's Br minus. And we are going to crisscross that 2 plus and that 1 minus. Our common multiple is 2. So how many of each thing do we need? We are going to need Mg1, Br2. Okay, you don't need the 1. It's implied if that ever tricks you. I mean, if you take a look at H2O, it's not H2O1. That just looks weird. So we don't want to do that in our work. All right, aluminum ion and nitride. All right, aluminum is Al3 plus. Nitride is in column 15, so that's N3 minus. So a 3 plus and a 3 minus. Ooh, if I crisscross these, I'm going to get Al3 and 3. Well, that 3 to 3 ratio can be reduced down. All right, I only need 1 of each one. So this is ALN, or Alan, as one of my cousins' names is. And that is our answer for this one. Okay, next we have iron 2 ion and chlorate. So this iron is in the middle of the periodic table. It gives me its charge. So that's Fe2 plus. Chlorate, I know from Nick the Crafty Camel, ClO3, 1 minus. Now make sure that you are crisscrossing the correct stuff. So here we have a 2 plus and a 1 minus. We're going to take a 2 here and a 1 here. And my formula will be Fe, and then I have ClO3. I'm going to need 2 of them. But I can't write 32 because that just looks very weird. So that's when I put my parentheses in front of the 2 around the ClO3s. This says that I need 2 chlorates in order to get my neutral compound. Okay, so that's how we work around that. That's why all those parentheses are in there. All right, ammonium phosphite. Ammonium, that's from our first set, NH4 plus. Phosphite, PO3, 3 minus. That's one less than phosphate, PO4, 3 minus. And just like before, make sure you are crisscrossing the correct things. Don't touch this bottom 4 or this bottom 3. You are only crisscrossing charges. I need 3 ammoniums and 1 phosphate. So I write NH4, 3. Now I need parentheses around it. And PO3, I only need 1 of them. Well, I don't need parentheses around that either. So we're going to clean that up and write NH4 taken 3 times PO3. Don't say the word parentheses. We say taken to represent the parentheses. All right? Kind of sounds like a scary movie with the taken, you know? All right. And then lastly, we have manganese IV. IV means 4. So that's Mn4 plus. And selenide comes from selenium, column 16, Se2 minus. So I have a 4 plus and a 2 minus. All right, let's crisscross them. So, to be consistent with my colors here, 4 goes here, 2 goes here, and I get Mn2Se4. Ooh, a 2 to 4 ratio. Can I do anything with that? Can I reduce that down? Yes, I can. Okay, a 2 to 4 ratio can be simplified to a 1 to 2 ratio. So the formula for this is actually MnSe2. Sometimes while you are doing these, you might spot that I'm going to need two 2 minuses to cancel out a 4 plus. So if that is the case, you can kind of just see ahead of time that you're going to need 2 of these. So if this is the MNs and this is the SEs, I'm going to need MN1 SE taken twice. All right, so to show you that again, over here we have our formulas for everything. Okay, so we have a 1 plus and a 2 minus. They're going to crisscross 2 and 1, and I get Na2O. Here I have a 2 plus and a 1 minus. I crisscross them for a 1 and a 2, and here's my MgBr2. A 3 plus and a 3 minus cancel each other out. I only need 1 of each. ALN is correct. If you were to write AL3N3, that would be incorrect, so please don't do that. Fe2 plus, ClO3 1 minus. I need 1 of these and 2 of those, so that's FeClO3 taken twice as my answer. Ammonium phosphate, NH4 plus, PO3 3 minus, this 3, this 1. I get NH4 taken 3 times PO3. And if I have a, excuse me, a frog in my throat. If I have a 4 plus and a 2 minus, you have to find the least common interaction between them. A 2 to 4 ratio can be reduced down to a 1 to 2 ratio, so that is MnSe2. All right, so make sure that you know your ions, you review them, and that is how we crisscross ionic bonds.